A helicopter is initially at rest on the ground at the origin when it begins to accelerate in a vertical plane. Its acceleration is 4.2 I plus 2.5 j meters per second for the first 20 seconds of its motion. The unit vectors I and j are horizontal and vertical respectively. Assume that the helicopter moves over horizontal ground. Find the height of the helicopter above the ground at the end of the 20 seconds. Find the velocity of the helicopter at the end of the 20 seconds. Find the speed of the helicopter when it is at a height of 180 meters above the ground. So let's have a little look at this then. So here's the question in summary form. So here's the acceleration. So let's get the velocity vector v. Integrate then. 4.2 times t, lots of I, plus 2.5 t, lots of j, plus a vector, a constant vector k, constant of integration. So v equals 0 and t equals 0 gives then well, it's clear that v is 0, t is 0, so these both will be 0, and that's plus a k, so k equals 0 then. So we get our velocity vector 4.2 ti plus 2.5 tj. Let's get the position vector now. So integrate once more. So this is the velocity, so integrate. So integrating then gives r is equal to 4.2 t squared over 2 will be 2.1, won't it? So we'll write that down straight away. Raise the power by 1 divided by 2. 4.2 over 2 is 2.1 plus 2.5 raise the power by 1 over 2j. This was I, of course, plus a constant of integration which we'll call k dashed vector wise. Okay, so r equals 0, t equals 0 then. Gives 0 then is equal to, this will be 0, this will be 0, plus k dashed. So that tells us that k dashed is equal to the 0 vector. Okay, so that's 0 then. So we've got r is equal to 2.1 t squared I plus 2.5 tj. Okay, t squared, sorry, over 2. Copy it down from here and here. So that's the position vector. So now let's have a look at the question. Find the height after 20 seconds. J is the height, isn't it? So part A, t equals 20. Height will be equal to 2.5. This j component here is the vertical, times the t squared, which is 20 squared. 400 over 2. 400 over 2 is 200. So it's 2.5 times 200, which is 500. Tap it in the calculator if you need to. 500 meters. So that's the height. Find v at 20 seconds. So part B. Let's just look at that again just to be sure. Find v at 20 seconds now. So t equals 20, and then into the velocity vector is equal to 4.2 times 20 is 42 is 10, so it's 84. Tap it in the calculator if you need to. I, and then 20 in here, 10 of these is 25, double that is 50. 50j, so that's the velocity vector. That's part B. Find the speed when the height is 180 meters. So let's go back to our position. The height is here. So here we've got this, which is 1.25. 2.5 over 2 is 1.25. T squared. That's the height, which is 180. So that tells us what T squared is then. 180 over the 1.25. So that tells us what T is. Square root of this. So we've got 180. Let's just look at this number. Divided by 1.25. 144. So square root of that is 12. Because this time is positive, isn't it? So we take the positive square root. T is 12 seconds, and that was when the height is 180. And now we need to find the speed. So V is this. So let's work with this then. When T, so it's 4.2 T and 2.5 TJ. There's the velocity vector in general. T equals 12. V is equal to 12 of these. 4.2 times 12. 252, which is 50.4. I. And then it's 2.5 times 12, which is 30. Let's just double check it. 2.5 times 12. 30. J. So the speed then, magnitude of the velocity is the square root of these two sides squared. Is equal to 50.4 squared plus 30 squared equals, okay, that's our answer. Now we need to square root the answer. We get 58.7 to three significant figures. 58.7, and that's the 3 SF, and this is meters per second, isn't it?